Hey everyone, that's my face as well as up here. My name's Mark Dalgleish. I've come here all the way from Melbourne, Australia, and I've been traveling for like 24 hours. Thank you, that's helping to keep me awake. It's like 4 a.m. for me, so this is really hard. So, as I'm sure you know or could guess, I'm a big fan of React for a lot of reasons. There's a lot of things to love about React, but there's one reason in particular that got me into it in the first place, and that is the fact that React does universal rendering. The fact that we can take our app and render on the server was a massive deal for me. And what that meant is that as front-end developers now we have a choice with our single-page apps. Do we want to server render or do we want to client render? It really depends on what kind of project we're working on. But I'm here tonight to tell you about a lesser-known third option that I'm pretty excited about. And that's the idea of bringing universal rendering to the world of static sites. How would you do that and why would you do that? That's why I'm here tonight. So to kind of get your head around where I came from on this concept and the work I've been doing, let's go back to the beginning of my journey on this. I've been working for the last couple of years at a company in Melbourne called Seek. They're the leading job site in Australia and New Zealand. Basically, if you're looking for a job and you live in Australia, you're pretty much going to Seek. This is the project that I've been working on. It's a complete rebuild of the UI, server rendered in React, and it's been a lot of fun, really cool project to work on. Now at Seek, leading up to this, for a number of years, we were already big fans of client-side rendering. It was a real no-brainer for a lot of reasons. The number one was that it gave us that app-like user experience that older technologies just didn't provide. But of course, as developers, there are a lot of good reasons why we liked it. It had a simplified architecture, separating the UI from the backend, which simplified deployments and of course simplified operations as well. So all around, it was a really nice move for us. And I'm sure it's true for a lot of you as well. For us, it was really the beginning of moving away from monolithic code bases where the UI and the backend and database queries and everything's all tangled up together. They started to break down really when single page apps hit the scene for us. But unfortunately, this approach had a fatal flaw that caused some pretty big issues for us. And that's the fact that single page apps notoriously will just show you a loading screen the first time you hit them if it's data intensive. And for some classes of applications, this is a critical mistake to make. And it's something that people have worked really hard to solve. Enter React, of course. More specifically, the fact that React can take an application and can render it as a string. This was the huge breakthrough that, like I said, brought me to React in the first place. Now, finally, we were talking about progressive enhancement again, whereas it seemed like all the JavaScript people had moved on from this concept. It was suddenly something that we were talking a lot about in the office, which led to search engine optimization being the key reason we moved in this direction. They kind of go hand in hand, as well as with that first load performance. So when that first request hits the site, the user gets that content really quickly, particularly if they're coming from Google. So when you think about search engine optimization, I like to think of it as also a user experience problem, that when a user hits your site from a search engine, they want to see that content ASAP. They don't want to see a spinner. So many weeks passed of us working on this project, maybe more than I'd like to admit. And components are everywhere. That's what React tends to do. And in our case, of course, they were universal components, specifically designed to function without JavaScript. Because, of course, there is a period of time when your site will render before the JavaScript kicks in on the client. Now, we looked at each other, of course, at this point as a team, and we said we should really start thinking about open sourcing some of these components. My natural thought then was, well, we want to demo on GitHub pages how these components can be progressively enhanced. But there was a problem with that, and that's the fact that GitHub pages is static. There's no node server running in GitHub pages. How am I going to show off what it's like to run this component on a node server when I don't have one? So I thought about it long and hard, and what I came up with was this idea of rendering the components to HTML at build time. And that's, of course, where Webpack comes in. It never ceases to amaze me how pretty much every problem I have can be solved by Webpack in some way. More specifically, the Webpack plugin system. So with Webpack and the plugin system that it provides, the plugins have access to every input file. They have access to every generated file or asset, and they can create additional files as well. There are lots of plugins that operate in this space. Extract text plugin that creates your CSS, for example, is probably the most widely used one. So my quick hack resulted in this project React to HTML Webpack plugin. And the idea was basically that in your entry file, instead of just running some code, you would actually export something. You'd export a React component. So in this case, it's just a simple hello world div. And by exporting that, and then you provide an instance of this plugin, you point this plugin at that component.js or whatever you called it, and you say you want to generate an index.html file. And here's a template that is a bit of a container content to go around that HTML that came out of React. So what's going on under the hood here? I know this is the kind of audience that probably wants to know a little bit of the detail. So Webpack plugins, for those who don't know, they're basically just classes in the old school sense. They're just functions with methods on the prototype chain. Here we've got the apply method, which hooks in to the compiler and listens for the emit event and basically does some magic in there where the dots are. So if we drill into that, basically what we're going to want to do is have access to the assets that have been generated by Webpack. There are a number of ways to do this. The two main ones are the compilation has an assets object you can look at. There's also a Webpack stats JSON object that you can get a handle on, and that has your assets by chunk name as well. So once you've got your asset, which is, in this case, it was the component.js file, getting the contents of the asset is super easy. You just call .source on it, and there you go. You've got the resulting contents of that file. So now that we have that output code that's been generated by Webpack, what can we do with it? What can we do now? Hate to admit it, but you'd want to eval it, I guess, at this point. But there's a problem with that, and that's the fact that JavaScript's built-in eval doesn't understand node modules. It's a totally different system. How do you get around this? Well, I had no idea that this existed until I stumbled across this problem, and that's the fact that there's a built-in VM module in Node. And if I'm just going to read out the docs for you, it basically says that the VM module provides APIs for compiling and running code within V8 virtual machine contexts. So basically, it's just a supercharged eval. It's super configurable. So what that lets you do, if you use this script constructor that's on that module, you can create a new instance of this script by passing in the string of the code that you want to execute. But importantly, on that last line, you'll see there that you can run that script in a new context that you define. You pass in the context that this script's going to run in. So if you want to create a node-like environment for this script to run in, you can do something like this. You can provide a global, exports, module exports, your own custom require, and then you pass that context in when you say run in the new context, and there you go. You've created your own little sandbox for the script to run. Luckily, because that's a little bit error-prone and fiddly, there's actually a package that kind of does this for you already on npm called eval, and it's pretty good. So if you pull in that eval package and you use this evaluate function, pass in the source, you'll see we've got this hook on this exported thing, whatever that is. So if that source file was exporting something, we now have a reference to it. So now that we can eval these compiled modules that came out of Webpack, what can we do with it? So in this case, we are trying to get a handle on a React component. So if we evaluate that source, we're going to have a component. And now we can React.create element with that component, and we can render that element to a string. And there you go. We've got our HTML that we want to output to the file system. And of course, Webpack allows you to create a new file with the contents being that HTML that we just generated, but I won't go into that now. Now, I quickly found that rendering only a single component wasn't enough. If I'm demoing something, I'm probably going to want to have multiple pages at some point and get a little bit more complex. So what happens if I want to render multiple routes? I want to hook it into React Router some way, if that's what I'm using, but I definitely don't want to couple myself to React Router, especially with their API changes. And if I'm going down this path, how do we decouple from React as well? Basically, what I'm looking to do is generalize the API from this, where you're providing a React component, to a more generalized render function, where the contract is just a function that returns some HTML, whether synchronously or asynchronously. And that resulted in the more final version of this concept, which is static site generator Webpack plugin. I'll admit it's named that way for SEO, basically, because I know what people are Googling for. And the idea here is that you can compile a render function, execute it at build time, but importantly, you have the full power of Webpack at your disposal. So everything you can do with Webpack, you can now do with your custom static site generator. Now this render function gets past some things because obviously it's not terribly useful to just render the same thing every time. So here the built-in local that gets passed in is called path. Now that we have a path, you're probably going to want to pass it to something like React Router. So now we've got React Router's server router. We're passing in the location as this path. And now this is starting to look a bit more fleshed out like a real application. Now, if you want to hook in Redux, it's starting to look a bit more like what you'd expect, where we're creating a store on every render. We're passing that store into the provider that wraps the server router that wraps the app. And if you want to do some data fetching, this is a bit of pseudocode basically, but if you've got some async way of fetching data, you can wrap that around the render to string call, and you can make sure that if there are any external dependencies that they're all resolved before you try to render. Which of course means that any library that's designed to work this way, like Redial, for example, will just work in this environment. So the key thing to note here is that even though we're building a static site, all libraries that sell themselves as being universal libraries can be used at build time. Now, for some of you, this may all sound very familiar because what we're doing here is we're going through a process of converting URLs to HTML documents. Really, it's bringing the whole server rendering workflow to your build step. So one way I like to think about it is, in some ways, you are still server rendering, it's just you're rendering on your CI server ahead of time. So how do we hook this up to Webpack? Basically, you just got to point it at a file via the entry. This is one of the critical things that's easy to miss. You've got to make sure the target is Node. Many people are unaware of the fact that Webpack can actually compile for Node as well as the browser, and that's the environment we're going to run this code. The other tricky bit as well is that you have to make sure that in the output, you're actually compiling it as a module using UMD or CommonJS so that, again, Node can understand this file. Now, when we get down to the plugin section of our config, we create a new instance of this plugin, point it at our render bundle, and then you pass an array of paths to render. So if you're rendering a blog, you just list out all the blog posts there. Now what's going to happen is that your render function is going to be called with each path that you defined. And for each one of those paths, a matching index.html file will be generated. So that means that you'll end up with a set of files that you can put on a standard static file host, and everything should just work. The paths should just work. Now, it didn't really dawn on us until a bit after we started hacking on this that we'd really stumbled on an important new pattern for us. What began life as a tool for static demo sites actually grew to become the basis of our own internal living style guide. So this is what our living style guide looks like, and it's showing the components that we have, the CSS styling that's available, the thought process behind it. But critically, the Living Style Guide features a complete static site to demonstrate its usage, and it's built using the techniques that I'm talking about. So the demo site is consuming its own style guide to generate a static site. So suddenly what we had is a method by which even our simplest pages, pure static pages, could be built with the standard universal toolset that we use on our most complex pages. So for us, that's React, that's using our style guide, it's using React Router and Redial for any data fetching as well. What this allowed us to do is, between these wildly different projects that we have, some are much simpler than others, we can make it so that stepping between these projects no longer felt like stepping between different worlds. Now, many more weeks pass, and this project starts to move beyond proof of concept and actually hits production. And of course, we had our first minor outage. Our React servers went down for a little bit, but all the APIs that we talked to were up because, of course, they're separated from each other. Now, we thought about this some more, and we thought, here's another problem that we have to deal with. Here's how we attacked it, or one of the ways we attacked it was whenever we run our Webpack build, typically we were generating our server build and our client build. We added an extra step in there to generate a static fallback build, essentially to build what you would have done in the old days of a pure static site. That's just now an extra output of the build. So we have a separate static deployment in case of emergency. If you really need to break that glass, it's there. So if you look at the source code for this site in production, of course you get the usual output from React, all wrapped in a div ID app in the corner there. And the static version is essentially the same, just like that. There's no pre-rendered content, it's just an empty div. Now, the initial container doesn't have to be blank. That just makes things a lot simpler. But if you look at a really good example of doing this the right way, there's a really great project called Colorable by Brent Jackson. And it's all about accessible color contrast, which I'm pretty passionate about. Now, this is up on GitHub pages, like I talked about. And it's got the little, it might be hard to see there, but the little sliders at the bottom there to adjust the colors. You can put in the hex, and it'll tell you what the contrast ratio is for that combination. Now, it's actually pre-rendered ahead of time, so when you hit GitHub pages, this is what you see every time, even if you've actually got some values in the URL that have been populated. So as soon as the client-side code kicks in, you'll see the colors change, you'll see the text change if it's actually a different ratio. But importantly, you saw something right away, even if it was not exactly the final version that you were going to see. Now, this also, as a technique, might sound a bit familiar because I think it shares a lot in common with a really popular approach for doing offline-first apps using service workers called the app shell architecture. And it's that same idea of trying to get as much as you can on screen as early as possible. There's a really good article up on SitePoint about this very similar concept of skeleton screens, of trying to make that first impression, that perceived performance as high as possible. By, again, rendering as much as possible ahead of time. But interestingly enough, even when we have nothing concrete to render, the most notable example of this is what Facebook have been doing with their timeline, where you'll see the sort of silhouette of content before the real content loads. Now, if I go back and look at this again, there's nothing on there that signifies who is going to get this timeline. So you can freely show this to anyone who's requesting the timeline before you pull in the real content. And you really get that sense of as a user, you get that sense of spatial awareness before the content loads. You kind of know where everything's going to be. You know the information architecture to some degree before things load, and it just helps that sense of speed rather than a blank page. So we're drastically improving the perceived performance with a bit of trickery rendering ahead of time. Now, what's great about this approach in terms of its implementation is that it's built with a low-level, unopinionated plugin that just expects you to provide a function, and it will run that function expecting some HTML. What this allows you to do is build your own opinionated tooling on top, and luckily that's what some people have done. There's a really great example in Gatsby, some of you may be familiar with it, by Carl Matthews. This is the animation on the README that shows kind of what it's like to work with. And it's your standard static site generator focused on things like blogs where you work in something like Markdown. But what's great about it is you've got the live reload workflow that we've come to expect in the React community. So if you're a React developer and you want to build a static site, you'll feel right at home with this project. So it's built with Webpack, React Router, and, as I said, static site generator, Webpack plugin under the hood. But the best part about it is that the Gatsby users can remain blissfully unaware of this. They can just focus on authoring their content. All of that is just implementation detail. So what started out as, I guess, something of a niche problem of rendering React components to put up on GitHub pages, I think what I ended up with, without planning on it, was a widely applicable solution that actually can be used in a lot of different scenarios. The key message, I guess, is that universal rendering doesn't have to only be for a select few people who need it, such as myself. Really, universal rendering is now for everyone. You can pull it in at any stage of your project, and you'll find a place for it. So now, as front-end developers, we have a slightly different choice. We can server render, we can client render, or we can statically pre-render, or even a combination of all three, as we've done, which is where I think things get really interesting for your own particular use cases. Ultimately, the reason why I'm here tonight is because I'm hoping to change the way we all think about static sites and what can be achieved with them, and hopefully I've achieved that tonight. That's it for me. If you want to talk to me after, I would love to talk to you about it, but otherwise that's it. Thank you.
Thank you for watching this talk. Down below you can find our channel ViennaJS, where you can find a lot of different videos about front-end and back-end JavaScript, and feel free to subscribe.